I welcome all the students in today's session where we are going to learn the implementation part of Bresenham's line drawing algorithm. Okay, in previous lecture we have seen all the details of Bresenham's line drawing algorithm theoretically, and now we are going to see today how to implement the Bresenham's line drawing algorithm through C program. Okay, so the implementation part of this practically how I can execute it. Okay, so I'm sharing my screen. Okay, I'm opening my PPTs. See, first of all, we are going to take a short review of Bresenham's algorithm. Okay, we have studied this in detail. Okay, but before I start implementing or showing you the C program, okay, let us have a quick review of the general Bresenham's line drawing algorithm. Okay, so you know why we call it as generalized, because it will plot or draw the line in all the quadrants. Okay, so first, second, third, fourth, all quadrants the line is drawn. So it is called as generalized Bresenham's algorithm. Okay, why it is called as integer? Because the advantage of Bresenham's algorithm is it uses all the variables as integer. Okay, there is no floating point arithmetic calculation. So all the variables are integer. Okay, now here the line endpoints are, so we are considering x1 and y1. This is my starting point of the line, and x2 and y2 is the end point of the line. Okay, x1 y1 starting point, x2 y2 is end point of the line which is entered by the user. Okay, same thing is here, all variables are assumed integer. Okay, all are integer, that is the advantage, no floating point arithmetic, algorithm is very fast. Okay, then we are having the sine function, so we uses the sine function, and this sine function is going to return me the -1 value. Okay, if the value passed to this function is less than 0. So if it is negative or less than 0, it will return me -1. It indicates that I have to decrement the value by -1. Okay, so that is plus -1 means it is, I get it as decremented by 1. Okay, if it is equal to 0, it returns 0. Okay, it indicates there is no need to, okay, there is no need to add any value into it. Okay, it may happen if the value of x2 or x1 is same, or y2 or y1 is maybe the same. Okay, in that case, and if it is greater than 0, it is going to return me the value 1. So I will increment it by 1. Okay, so this sine function will decide whether I am going to increment the value or x and y value by -1, whether it is plus 0 or whether it is plus 1. Okay, so this is initialization of the variable. Okay, so x value is equal to x1, y value is equal to y1. Okay, so that is my starting point of the line. Okay, because that is assigned to x and y. This is going to change, and this is going to calculate the next pixel or the value. Okay, then I'm having the delta x and delta y. We are going to calculate the value of delta x. Delta x is nothing but absolute x2 minus x1. Delta y is absolute y2 minus y1. So calculate delta x and delta y. Okay, now here we are going to calculate the s1 value, which is nothing but I am passing to the sine function x2 minus x1. See, suppose I am drawing the point or plotting the point maybe into the quadrant second and third, where the value of x is negative. Okay, so in that case, suppose my x1 value is -100, this is minus, so obviously I have to decrement from starting point. So s1 value is used. Similarly, I am using s2, okay, which is equal to sine I am passing y2 minus y1 value. Okay, so this s1 and s2 will decide whether I am going to increment the value, decrement it, or adding only 0. Okay, now after this interchange variable is very important. Okay, why this interchange variable is used? Because we are always assuming that the value of delta x is always greater, which I am using for my for loop or while loop. Okay, but if the value of delta y is greater, so I am checking the condition. If the delta y is greater than delta x, if the value of delta y is greater than delta x, I am going to interchange the value of delta x and delta y. And so this is the interchange or swapping of delta y and delta x. And I put the interchange is equal to 1. Okay, so we have to keep in our mind is, if interchange is equal to 1, indicate that the value of delta y is greater than delta x. Okay, else interchange is equal to 0. Okay, so interchange equal to 0 clearly indicate that the delta x is greater than delta y. Okay, so that's why we are having this interchange variable. Okay, moving to the next slide. Okay, so what we are going to calculate here is Bresenham's algorithm uses the error term. Okay, so error term is calculated. So E bar, okay, so E bar or error term is equal to 2 into dy minus dx as per the algorithm. Okay, then I'm using the for loop from which is starting from I. So I is equal to 1 to delta x. Okay, for loop is start from I is equal to 1 to delta x. What I'm going to do is I'm going to activate the first pixel, set pixel x comma y, plot the first pixel. Okay, and after plotting the first pixel, we are going to check the sign of error term. Okay, so I'm having the while loop while e bar is greater than 0. Okay, if e bar is greater than 0 means sign of error term is positive. Okay, then what I have to check whether it is interchange is equal to 1. Okay, what is meaning of interchange is equal to 1 is if interchange is equal to 1 means delta y is greater, and if delta y is greater, the x depends upon the error term. Okay, x value depends upon the error term. So x is equal to x plus s1. Else, this else indicate interchange is equal to 0. Interchange 0 means delta x is greater. If delta x is greater, the y value depends upon the error term. So we are having y is equal to y plus s2. Okay, and again the e bar is calculated, error term is recalculated, and again I continue with the while loop. While loop is continued, again e is greater than 0, again we just perform this operation. Okay, now outside this while loop, when I come out of this while loop, I have to increment the variable. Okay, one variable is always incremented or decremented, and other depends upon the error term. So if interchange is equal to 1, okay, again I repeat, what is interchange equal to 1 means the what is greater, delta y is greater. If delta y is greater, y is always incremented. Okay, so y is equal to y plus h2. Else means interchange equal to 0, indicate delta x is greater and x is always incremented by 1 or by plus s1. Okay, again the error term is calculated here. Okay, and the loop is continued. Okay, so this is what the algorithm. Okay, the quick review of our Bresenham's line drawing algorithm, and our actual aim is to understand how it is implemented through the C program. Okay, that is what our main aim of this. Okay, so I just close my PPTs and open the Turbo C editor. Okay, I minimize the PPTs. Okay, and I am going to open the Turbo C editor here. Okay, so instead of wasting the time, I will not type the complete program. Okay, so instead of typing the complete program, rather I will go for opening the program that is already have done. Okay, I have typed the program. So I open this program. Okay, what is our purpose of the program is program to implement the Bresenham's line drawing algorithm. Okay, this is our program to implement Bresenham's line drawing algorithm. Hash include htio.h, conio.h, and we have to include math.h. Okay, what is included is math.h is include the mathematical function. So all mathematical functions are available in math.h. Okay, then we are including the graphics.h, include graphics.h, which is having the graphical function. So whenever I am using the put pixel function, okay, circle any function related to graphics, I have to include the graphics.h. Okay, so here I think before we start with the main function, I think we have written the sine function here. Okay, so this function, what is sine function does? This function decides whether to increment or decrement. That is, shall I go for +1 increment value, or shall I go for -1, or it may be 0. Okay, so we have written this sine function first. Okay, in the sine function, you know that if the s value, whatever value I am passing to sine function, if s is greater than 0, it is going to return 1. So I have to increment it. Okay, so s is equal to 1 means increment by 1. Okay, or rather I say it is increment by 1, that is nothing but +1. Okay, else if the value of s is less than 0, means it is negative, what I have to do is, okay, decrement. Okay, or rather we say it is -1 value. Okay, decrement. Else return 0. Okay, return 0 means no change. Okay, I may have my value of the past value, maybe x2 minus x1 may be same, or maybe y2 minus y1 may be same. Okay, so this is what our sine function. Now after this sine function, see what we have to go for is we are including the main function. We just go through the main function. Integer GD is equal to detect, GM is equal to detect. We have learned in the previous program. GD stands for graphics driver, GM stands for the graphics mode, detect indicate auto detection. Now here you can find all the variables I am declared are integer. Okay, that is what the advantage of Bresenham's integer algorithm. Okay, there is no floating point arithmetic, all the variables are integer. So integer x1, y1, starting point of the line, integer x2, y2, end point of the line, x and y initial values. Okay, then temporary whenever I am swapping the values, then I am using the interchange here. So this interchange will decide whether the delta x is greater or whether the delta y is greater. Okay, again dx and dy, delta x, delta y, E is used to calculate the error term, I is used for the for loop, S1 and S2, this sign function value S1 and S2 will decide whether to increment or decrement. Okay, so then I initialize the graphics here, that is init graph. Okay, init graph ampersand GD ampersand GM. Okay, and this is for initialization of the graphics. Okay, now what is the first thing that we are going to do here is we take input starting and ending point of the line. Okay, we are going to take the input of the x1, y1 and x2, y2 using the printf and scanf. Okay, so here I take ampersand x1 comma ampersand y1 means starting point of the line, and here we are going to take the end point of the line. Okay, starting point of the line and end point of the line. Clear? Okay. Now we calculate here dx and dy. Okay, the value of delta x and delta y is calculated, absolute x2 minus x1, absolute y2 minus y1. Then here we calculate s1 and s2 as per our algorithm. S1 is equal to sin x2 minus x1 and s2 is equal to sin y2 minus y1. Okay, now after this what I have to decide is I have to decide whether the delta y is greater than delta x or not. Okay, I am assuming here delta x is greater, but if delta y is greater, okay, delta y is greater than delta x, okay, what I am going to do is I just put this value of interchange is equal to 1. Okay, so we are going to change the value of interchange is equal to 1, else I am going to put the interchange value is equal to 0. Okay, so I am going to change the dy is greater than dx, interchange is equal to 1, else it is interchange value is equal to 0. Okay, so that we have done here. Okay, now what I am going to consider here is x is equal to x1, y is equal to y1, initial values are there. Here E error term is calculated is equal to 2 into dy minus dx. Okay, calculate the error term. Okay, now this particular algorithm, okay, that is what we are considering is works in this particular algorithm works in all the 4 quadrants. Okay, not only a single quadrant. Okay, so we have divided the screen into 4 quadrants. This is additional thing. This is not there in the DDA, but we are considering for the generalized algorithm. Okay, so I divided the screen into 4 quadrants. First, I draw the horizontal line, okay, at the center of the screen. Okay, center of the screen. So my value of x is 0. Okay, center of the screen for y value 240. My x ends at 640. I am having the resolution of 640 by 480. 640 x values, x pixels, and 480 y pixels. Okay, then I am going 240. Okay, so y value will same. So it will draw the horizontal line at the center of screen. Okay, then I am drawing the line which is vertical line at the center of the screen. Okay, so my x value will be in this case 360, y value 0, again 360 and 480. Okay, so I am drawing the vertical and horizontal, these 2 lines, and divide the screen into the, I am going to divide the screen into 4 parts, rather 4 quadrants. Okay, now after that this loop is important, that is incrementing through this particular loop. Okay, now the for loop is there for I is equal to 1, I less than or equal to delta x and I plus plus. Okay, so first value that I am going to put is put pixel 360. Okay, now put pixel x and y and white color. This is the normal put pixel function. Okay, but now here as I am dividing the screen into the 4 quadrants, my 0 0 is not here. Okay, my 0 is not at the left side bottom corner or left side top corner. My center of the screen is at the center, it is 0 0. Okay, so at the center 360 240 it is 0 0 value actually. Okay, so what I'm going to do is I'm adding 360 into x and I go for 240 minus y. Okay, so 240 value, because 360 and 480 it is my actually center of this particular screen, but now it is considered as a 0 0 value because I divided my screen into 4 quadrants. Okay, so that is the only reason we have added 360 plus x and 240 minus y, else it will be normal x and y. Okay, now after that I am having the while e greater than 0 if error term is positive. If interchange is equal to 1, again interchange equal to 1 means the value of delta y is greater and x depends upon the error term, so x is equal to x plus s1. Else, indicate interchange equal to 0. Interchange is equal to 0 means the delta x is greater and y depends upon the error term. We are considering y depends upon the error term. Again, the error term is calculated here. Again, the while loop continue. If the error term is again positive, again this is executed. Okay. So outside the while loop, I just have to check if interchange is equal to 1. Delta x is great, delta y is greater, y is always incremented. So y is equal to y plus s2. In else part, okay, indicate delta x is greater and x is equal to x plus s1. X is always incremented. Okay, and then again error term is calculated is equal to e plus 2 into dy. Okay, and I continue and again I plot the next value. Okay, because here I have got the updated the value of my x and y. I'm going to put the next pixel, activate the next pixel, and this is continue until the value of I is less than or equal to dx. Okay, get ch to see the output of the program, and at the end you close the graph. As we initialize the graphics function, we are going to close graph. Okay, so this is what the program implementation program of the Bresenham line drawing algorithm. Okay, we are more interested into the output of the program. So I just use F2 to save the program, F9, okay, no errors, control F9. Okay, now here it is going to ask me the enter starting point of the line. Okay, suppose I want to plot the line into the first quadrant. In the first quadrant, x and y, all the values are positive. Okay, there is no negative value. So I just plot it as x1 is 100, y1 is 100. I want to draw the point from 100, 100 to 200, 200. Okay, so just see output. Yes, you can find it here. The screen is divided into 4 quadrants, and in the first quadrant, okay, I considering this is my 0th value, center of this, okay, screen is 0, 0, and I have plotted 100 and 100. It is same as per our graph. Okay, normal graph that we are considering. Okay, so it is correct, 100, 100, 200, 200. Okay, now suppose I want to draw it into the second quadrant. Okay, you can find in the second quadrant the value of x is negative. Okay, so again I will execute the same program. Okay, F2, F9, control F9. Okay, what is happening? My value of x, okay, is negative. So I will go for minus 100 to 100, means x1 is negative, and from y is also negative, x2 is also negative, so it is minus 200 to minus 200. Okay, minus 100, sorry, not minus 200, it is 200, because x is negative and y is positive. Minus 100, 100, minus 200, 200. Yes, you can find that it has overlap because we have not cleared the screen before drawing. Okay, but you can find the line is correctly drawn into the second quadrant. Okay, you can find the starting of the line is minus 100 x value. Okay, and it is y value is positive. Correct. Now suppose I want to draw the line into the third quadrant. Okay, third quadrant, what is going to happen? This is first, second, and third quadrant. In third quadrant, x and y both are negative. Okay, so I just show how we can draw it. Okay, control F9. Okay, now I am having the value minus 100 and minus 100. Means both the x and y values are minus, negative, from minus 100 to minus 200, minus 200. Okay, suppose I am showing minus 100 and all the values are there. Yes, the output is very correct. You can see the output. My line is drawn into the third quadrant. Okay, where the values of x is negative as well as y is also negative. Okay, now let us draw the into the fourth quadrant. In the fourth quadrant, what is going to happen? X value positive, but the y value is negative. Okay, so let us look at the output of this. I just go for control F9. Okay, enter the starting point of the line. So x value is positive, so it is 100. Y value is negative, minus 100 to 200, and y value is negative, minus. It is not necessarily you go up to the, okay, 200. You can have minus 150 also. Okay, so the y will displacement of y will be for 50 points and x will be maybe 100 points. Okay, so I just plot it. Yes, you can find it as it has drawn into the fourth quadrant. value of x and x2 are positive, okay, whereas the y1 and y2 are negative, minus 100 to 150. Okay, so the displacement is, so this indicate that if you can see the output, it indicate that, okay, how it is going to display the or plot the line using the Bresenham, generalized Bresenham's line drawing algorithm. Okay, so this is the output and the program very much clear that whatever we have learned theoretically can be implemented into the C program with the help of the, okay, any Turbo C editor. You can find that the program is available. Okay, program to implement the Bresenham line drawing algorithm, and we just go for the program just now we have seen. Okay, as per the algorithm we are going to implement it. Okay, and this shows the implementation of the Bresenham's line drawing algorithm. It is not necessarily that you should draw the line in only one quadrant, but it is possible that your line may move from minus any one quadrant to the another quadrant also. Okay, just so let us check for this. So I execute the program again, Control F9. Okay, suppose I want to start from the x value in the negative value. Suppose it is my x value is minus 100. I want to start my x value is minus 100. Okay, my y value, suppose I take it as the 50. Okay, so I'm moving from the minus to plus quadrant, not necessarily in the one quadrant. Okay, but now I want to move from minus 100 x value to plus 100. You can find. Okay, minus 100 to plus 100, and y value, suppose you just move from 50 to 100. Okay, so I'm moving from one quadrant to another quadrant. Okay, so you can find that what is going to happen. Yes, you can find the correctly the line is drawn. My, just look at that. My starting point is minus 100. You can find x value is minus 100, y value is 50. Very correct. Okay, and you can find the end point. Okay, x value is 100. So now x is moved from minus value to plus value, and y value is also 100. Okay, you can find that. So it is going to draw the line. Okay, maybe starting point may be in any quadrant and end point may be in any other quadrant. So it is draw the line appropriately in the all four quadrant. Okay, that's why it is called as generalized Bresenham algorithm. Okay, I hope so all of you seen our seen the output. Okay, and it will help you to implement it as a program. Okay, so this is what we have, okay, learned today, and our topic that I hope all of you understood it. Okay, and you have seen the practical implementation or in the through 3 program how I can implement generalized Bresenham's line drawing algorithm. Okay, thank you all.